Hi everyone, today I'll be talking about how to solve simultaneous equations using substitution method. I have a previous video on how to use elimination method to solve simultaneous equations. So for today's video, it's going to be a short one, and I'm going to focus on how you use substitution method to solve actually any sort of simultaneous equations involving two variables. So we have the variables x and y here. So the first equation, we have 2x minus 3y equals to 9. Alright, so I'm going to write it here, and then I'm going to call this equation 1. And the second equation, we have 3x plus 2y equals to 7. Okay, I'm going to label this as equation 2. And in substitution method, what we want to do is to actually isolate x or y. So that means making either x or y the subject of one of the equation, and then replacing the x or the y in the other equation accordingly. So what I mean is this. So I'm going to identify, for example, equation 1, and you can, for a matter of practice, use equation 2, isolate either x or y, and then see whether you can achieve the same result. So equation 1, I'm going to isolate x. So that means I will need to add 3y on both sides, so that's going to result in 9 plus 3y, or more habitually what I normally do is to write 3y plus 9. Okay, and then the next thing is I'm going to divide 2 on both sides, and that's going to have x equals to 3y plus 9 over 2. Okay, and I'm going to name this as equation 3 once I have isolated x, or should I choose to isolate y, alright, as a subject of the formula or the equation. So here I've already isolated x. What I'm doing here is to represent x in terms of y and other numbers. And what this does is I can now replace the x in equation 2 with 3y plus 9 over 2, and then the whole of equation 2 will now only contain y and not x at all. Okay, so once I remove the x and the whole equation only contains y, then I can solve for y first of all, before I substitute back to any one of the equations and to find what's the value of x. So that's the kind of understanding that we need to have. So I'm going to substitute equation 3 into definitely equation 2. You can't substitute this back to equation 1 because it's going to go in the loop. So what I do next is to replace the x, but before that I would just first of all want to write it like this for now. Okay, because this process of 3x is actually, this term 3x is actually 3 multiplied with x, and then that multiplication is with a fraction now that you see what's happening in equation 3. So I am replacing this x here with 3y plus 9 over 2, because I said that x equals to 3y plus 9 over 2. It's the same thing. So I'm going to replace this x. So I'm going to remove it away and replace it with 3y plus 9 over 2. Okay, so the next step, I'm going to do two things at the same time. The first thing I'm going to do is to multiply the 3 into the numerator. Okay, so I'm going to have 9y plus 27 over 2. And then the next thing I'm going to do is actually to subtract 2y on both sides. So that process is going to move the 2y, sort of move it to the right hand side. So that's minus 2y appearing on the right. And then what I'm going to do next is actually to multiply 2 on both sides. So that's the sort of cross multiplication that we always talk about. Okay, so multiply 2 on the left, the denominator 2 is gone, and I'm going to multiply 2 on the right. So this is it. Or if you're comfortable algebraically to do this, you can directly just multiply this, and what you're going to get is actually 14 minus 4y. Okay, so I've now removed the fraction So what I'm going to do next is to finally solve for the y. So I'm going to add 4y on both sides. Okay, so 9y plus 4y on the left, and I'm going to subtract 27 on both sides, and then it's 14 minus 27, so I'm going to get 13y equals to negative 13. Okay, and then finally I will have y equals to negative 1. So that's all good. We've now found the value of x. So in terms of space, I'm running out a little bit. So I'm going to take this to a second column. Okay, and what I'm going to do next is to substitute y equals to negative 1 into one of the equation. Now obviously I will want to substitute back into equation 3 because that itself already has x as a subject. So we'll substitute this back into equation 3, and then what I'll have is x equals to 3y, and I know that y is negative 1 plus 9 over 2. And then if I use a calculator to calculate this, it's going to give me x equals to 3. And therefore, my answers will be x equals to 3, y equals to negative 1. So I hope this really quick example will help you to see the processes that is required in using the substitution method. Alright, it's in general, all simultaneous equations involving two unknowns are solvable by using substitution method. It's just that you need to deal with the algebraic fraction at times, and so therefore it may be a bit daunting for some people who are not so comfortable with algebraic fractions, but otherwise this is something which is quite applicable over all the simultaneous equations involving two variables. So I hope this helps you to understand this, and until the next time, thank you and goodbye.